Hey friends, welcome back to the channel. And in this video, let's discuss how to pick the right database. So till now we had discussed different kind of databases, be it relational database, non-relational database, and different kind of NoSQL databases like document DB, graph DB, key value stores, etc. Now in this video, let's discuss what are the parameters or what kind of trade-offs that you need to keep in mind for each database and how you can use or pick any specific database according to your use case. So let's get started. So first thing that we need to understand is there's a common myth around the databases, which states that NoSQL databases scales and SQL databases doesn't. Well, in real life, it is not like that always. We have ton of example where SQL database scales exceptionally well, and there are some cases where NoSQL databases don't scale that much. So we can scale SQL databases because by dropping out some kind of constraints and by manual sharding, but in the case of NoSQL databases, sharding comes out of the box, so that is an advantage using that. Now, but so the core principle that you need to understand is that every database is created to solve one peculiar problem. So for example, Redis, it is a key value store. So it is solving that particular problem of getting a single ID in a with very low latency. Or if we talk about Neo4j, it is based on graph DB, and we can have some kind of complex graph algorithms on that. So we need not to pick our favorite database, but what we need to do is understand the problem first and then pick the database according to that use case. So for example, if we just have a look at this detailed example of, let's say, e-commerce. So if we have a look, if our main requirement is having a users, so we'll be using a PostgreSQL and we'll be sharding it by user ID. Now, why? Because it is structured and we have ACID properties out of the box, which is atomicity, consistency, etc. If we talk about product catalog, means we have tons of product on our website, then we'll be using MongoDB. Why? Because it is quite flexible schema, and which is beneficial because different categories have different attributes. Or we can have something called as the session store. In this case, we'll have Redis. Why? Because it is fast. It has the data in memory, and it has something called as TTL, which is time to live, in which we can set the expiry of that data. So here we can have some time allocated before the expiry. For the searching in our catalog, so let's say we search blue jeans or t-shirts. So for that case, Elasticsearch DB would be the best thing to be implemented. Or we need to have order history. In this case, we'll be using key value stores like DynamoDB. Why? Because it can be scaled massively, and simply we need just a key to get the order history given the order ID or something. If we are talking about recommendations, so if one product is selling a lot and maybe we need to recommend it to others, in that case we can have a Neo4j, which is a graph database, which is quite beneficial when we are talking about recommendations sort of database. Or if we talk about real-time inventory count, in this case again Redis is going to take our hit because it is storing data in memory, and we can have a fast atomic increments. Now if we are just designing a single app, we can see that 7 different kind of databases can solve its specific or peculiar problem. So this is the one thing that you need to keep in mind before coming up to any of the single database, and you need to understand the requirements and the trade-offs both. So let's discuss what are the decision framework and key questions that you need to understand. So first is what data you are trying to put in your DB. Is it structured, semi-structured, unstructured, and how much is the data? What is the scale of the data? It is in several GB or it is in terabytes, multiple terabytes. What is the scope of the data that you are going to store? Second is how you're going to access it. Is it a simple key value store? Does it require complex queries to get the data that you need? Or do you need to some kind of partial queries on your database? Do you need joins, or you need some complex graph algorithms on your graph? So how the access your database, that is the second point. Third is, what are the guarantees that you need? Do you need strong consistency? You cannot compromise on that. Do you need ACID transactions out of the box? For that case, SQL databases are the best. Do you are you okay with the eventual consistency, or if it is very critical for you that data is correct all the times? And fourth is, do you need any kind of special features like TTL, time to life, or expiration of the data? Do you need some kind of advanced data structures? Do you need something like Bloom filters, Hyperlog, or do you need some kind of search specific requirements like full text search? So all these four key questions you need to first understand before coming up to a database. Now, before jumping in to some real world scenarios, let's understand what are the common anti patterns that you should avoid. So, first is, I'll use NoSQL because SQL doesn't scale. So, we have already discussed it. It's not not completely true. Second is MongoDB for everything. So, this is a common misconception. Most of the people uses MongoDB for everything. Well, it is good for many of the cases, but not all of the cases. GraphDB because my data has relations. Well, if you don't need that complex graph algorithms and some sort of recommendation or social network engines, you don't need that much that much data to be in your GraphDB. Just in case it scales later. So solve today problem. Don't just procrastinate and just ignore. And fifth is ignoring team expertise. So if you are familiar with a specific database, it is good to go deep down into it and make some changes in that database uh, rather than getting to know a completely new database and then understanding it. So it is also a matter of time. If you have that much time, if your team allows that, you can spend some kind of time getting up to a new DB and understand the requirements or build up some of the requirements. So you can go through that path as well. Now let's understand what are the some real world scenarios and how you can choose the database. So first is the payment system. So in this case, what happen is your data is going to fit in a node. You need strong consistency. This is the most important part for the payment systems. You need asset properties and you need data correctness. Now in this case, the straightforward choice is going to be MySQL or the relational databases, because asset properties comes out of the box. You will get strong consistency and data correctness. So payment systems go straightforward with the PostgreSQL. Also, the data is going to fit in one node. If not, you can manually shard the relational databases. Second, you need to have some kind of analytics dashboard. Now, in this case, you need to have some kind of complex queries. You need aggregations just to have some kind of relations between the different analytics. And in this case, again, you can go with the SQL databases. Third, if you're talking about session store or a cache, and in this case, best choice is going to be Redis because data is stored in memory. We'll have very low latency. We'll have key value access, and we can have a TTL associated with the data. That is how long the data is going to be stored in the memory. Now next, let's understand which is the leaderboard or the real-time counters. So in this, we need some kind of advanced data structures like the sorted sets. We need very low latency and the data can fit in our memory. The choice is obviously going to be Redis. Now, fifth, let's understand how the e-commerce business is going to work. Now, in this case, we'll have tons of data and we cannot store in one node. We can have, let's say, sharding as well. And if the team has SQL expertise, then we can go with the SQL databases, because we can have manual sharding, we can drop off some of the constraints like foreign key checks, etc., and we can go with that. If not, we can choose some other uh, document DB, which is NoSQL database, which is quite similar to relational databases. Six, let's understand what are the user profiles. As the database associated with user profile. So this is quite straightforward. We need a key value store, and we need sharding. We need to scale it. Uh, we need to scale it as much as possible. So the clear choice is going to be DynamoDB and Cassandra. And let's say we have social network in which we need to have some kind of, let's say LinkedIn, we need to show some kind of connections or the mutual friends, and we need to have some kind of recommendations. We need graph traversal for that. So straightforward choice is going to be again the graph databases like Neo4j, dgraph, etc. Now, taking up all these examples, we had gone through this decision flow chart. So what we had started with, what problem am I solving? So if we talk about social network side, we need this kind of graphs, nodes, and edges between the friends and all. So this is the starting point. Initially, what you are going to solve. So first is what problem am I solving? Second is what's the data? What's the structure? What's the volume? How the data is going to grow? How much we have to scale our database? Second is how am I going to access it? Is it going to a simple get put queries? Is there going to be graph traversal, complex queries? What are the guarantees I need? Any special features? What are the team expertise? And if there's a specific database that fits all our needs, we are going to pick that. If not, we'll consider taking up any prototype for us, and we'll see what are the trade-offs that we need to make as per our requirements. And if those trade-offs are okay, we are going to go with that database. If not, we are going to reiterate. So this is how the cycle is going to be. Now let's so these are the few unique properties that popular databases gives. So about this in detail, we had discussed about in our previous videos about relational databases and non-relational databases. And in the end, there's just some key takeaways that we can have is that don't pick your favorite databases. Every database solve one problem really well, and we need to understand the requirements and the trade-offs that any databases give. Understand your problem first, then pick the database, and you should be creative. And you need to understand the team expertise, what are the requirements, and all things in general. So that was the whole discussion about how you can pick up the right database given your given your needs and your expertise. So hope you found this video amusing, interesting, and informative. So that's it for today's video. See you in the next one.